Okay, this is my good friend Steve Thomas. He's going to talk about defending with two-factor authentication. That's it. Pay attention, Steve.
So, I guess, as you already said, I'm Steve. You may know me as Scoops. So, the different types of two-factor authentication. There's time-based top key. That's usually just like a 6-digit PIN that a dongle tells you, or smartphone. Usually it's like 96 bits private key, something like that. Then there's challenge response. This is usually more secure because it's usually like a large key with and the response isn't just like 6 digits. It's hash output from like HMAC. There's counter mode like hotkey, which is similar to top key in that it has a secret key somewhere around like 96 bits, and it's a 6-digit PIN that you type in. There's YubiKey, which is basically AES encrypted counter mode with like some other fields in there, which is fairly secure. The only thing with that is that it's most of it is done authentication as a service. So if well, everyone usually leaves the default key in, which only works with YubiKey. They have the basically the shared key where they just have HSM that has an encrypted version of it. Well, a key that decrypts it. Anyways, so anyone that gets into YubiKey can then just say yes if it sees something. So, but it's probably fairly good. Then SMS, so cell phone. But yeah. Yeah, that time-based. It's like, well, like RSA. Smart card? Oh, no. But, well, this is, I'm not even going to talk much more. I was just, thanks. Yeah. So, the threats. Stolen password. Basically, then it relies then solely on the second factor. So for top P or hotkey, those with the 6-digit PIN, your password is then basically, well, to get in, you'd have to break a 6-digit PIN. So lost or stolen, stolen second factor, then it's normal, just password. So the ones that were, well, I'm not really going to talk much more about either of those because they're not really important. But so the next two, online guessing, that is problem. Then there's timing attacks, such. Well, I have slides for this. So there's. For online guessing, you want a rate limit, you know, per user, per IP, except for with IPv6, that kind of doesn't really matter anymore because there's so many IPs. And you can actually get like a 32-bit network address field that you can just cycle through. So, but for the time being, and even if you don't, you still should. Rate limit. Check. Okay. So you want to check both of them and make sure that you don't say which one fails, because then it's basically the security of the password, the strength of your password times the strength of the two-factor, or your password plus two-factor. So if your password is like, it would take 1 billion guesses, and the two-factor is 1 million guesses, it would be 1 million, 1.001 billion guesses for plus, or what did I say? Billion, million, quadrillion, yeah. So 1 quadrillion, which would be a lot harder to break. Timing text. So you didn't want to say which one failed before so what you don't want to happen is, let's say you have a really strong password hashing algorithm that takes, a decent amount of time. If you check the second factor first and then just return, then you'll know that the second factor was the problem. Well, timing texts don't really work too well because the thing that you're trying to get keeps changing for the second factor, but it's still important to check second factor constantly, or in constant time. So if they're for like the time-based ones, you usually check 2 before and 2 after, so it covers like 5 minutes in case time skew. So even if you do actually find the code correctly, you should check all 5 just in case. There's, they're very close to you so that they can actually tell. Obviously you want to check both in case one failed. So this is basically so that you can have the password strength times 2 factor. If you do check the second factor first and then check the password, that is almost equivalent to the multiplication, because you have to keep guessing the 2 factor, which keeps changing, so you can't just replay. Unless there are replay, you can just keep sending the same guess over and over, and it just keeps saying yes. Unless the second factor, the key size for that is small. There was actually a case where a company thought they were using 96 bits, but they were using 48. So after 2 correct guesses, you would then have basically 40 bits. So then there would only be 8 bits left that you don't know. Well, you would brute force the whole entire range to see which ones actually were valid. Then you'd have basically 256 guesses that you'd have to make. Then you would have enough to know what the key was. It was encoding error. They encoded, there was the private key, or shared key, that was then in hex, then in base 32. So, yeah. I already, sorry. So, yeah, you want to check all the time. Oh yeah, so, I already covered, sorry. So, you want to keep track of everything in the last time span, so that you can't just keep guessing those. Oh yeah. Also, you don't want to update. So if you do get the for top P, if you get the second factor correct, then usually what the code does is it adjusts for the time skew. You don't want to adjust it until after you've also verified the password, because the database update will take some time. Thus, you might be able to tell whether you got the password correct for so you should have 2-factor authentication optional. Also, SMS, that is one that you should avoid. Is Pear here? Hey! Yeah, so for Twitter, Pear had a problem because Norway isn't supported, so, right? So, login process, so you would have 3 fields: username, password, second factor, which is optional. If it is enabled, so what you would do is you look up the username. If it's enabled, then you would then ask for the second factor, and then you would check both the password and the second factor. Otherwise, you would just check the password as normal. So I forgot to tell the company about this. So, well, I told them, but I didn't tell them I was going to do a talk and that they should have a fix. So, Star company. This is what they do. Oh, what they do is they do client-side crypto. So all the encryption is done client-side, and then the only thing on the server is encrypted data. So, you know, they had a similar misunderstanding as Krypton. So they had Krypton. They're always saying zero knowledge. They don't want anything to know about your password. But to do this, they used SRP. But the server has, well, besides the fact that if you do any encryption based off a password, if it's public key or authenticated encryption, both of those have enough, you know, information to say whether you got the password correct or not. So those are password hash equivalents. But with SRP, basically it's a password hash equivalent in the database that they use for authenticating with SRP, which is my segue. I don't know where to actually put this in. So in a, well, this has nothing to do with that. I just wanted to talk about it because I couldn't talk about the Star company. So I took out some slides. In an audit for Krypton, they were told to do elliptic curve SRP, but none exist or something. There is a few, but they have major problems. I forgot his real name. PDP11 hacker. He was trying to do. Oh, hey, he's here. He was trying to do elliptic curve SRP, and we were going back and forth. And one of the things he came up with was using a P and a Q, which are 2 points on a curve. But he wasn't able to actually get anything that worked. But so I came up with this. So one of the things that might be weird looking is the division of x. Basically, since elliptic curves are on a cyclical group that has a prime, you can do, and basically what you're doing is multiplying in there inside this cyclical group. So what you can do is, so P being the prime number for the cyclical group size, you can do x raised to P minus 2 mod P, and that gives you the modular inverse. Yeah. So if anyone can break this, there's a drink with your name on it. But yeah. Anyway. So the worst I've ever seen. I'm still going to talk about it. I'm just not going to say. I had more in depth. Anyways, so the login process is get username and 6-digit second factor PIN. If wrong, go to fail. Then, so if they get it right, the server gives you a challenge, which is a message encrypted with your public key and your encrypted private key. So what? So this is a password hash equivalent that is being protected by a 6-digit PIN. Then, if the response is correct, then you're let in. So the attack, you guess the 6-digit PIN until you get it right, assuming that there's two, plus or minus 2, that's 5 because you got the original and the 2 on here for time skew. They originally had no limit for guessing, but so I just went with like 10 guesses per second, so that I didn't the pin, yes, 6-digit pin. Oh, what? No. This is the second factor. There's a password and the second factor. So the six, that's your password. Then it's I actually forget what they use. I think it's probably PBKDF2. Probably should know that. Anyways, so this is just guessing the 6-digit pin. It'll take on average 3 hours. Since I told them this, they changed it to a 10-second rate. So you can only do one every 10 seconds. So now, on average, it's 12 days. So after 12 days, you get a password hash equivalent that you can do offline attack. And oh wait, that's not set. There is a problem with this. Since you're guessing every 10 seconds, the legitimate user, when they try and go, they're not going to be able to log in because it's going to say, wait 10 seconds, and then it will keep saying that for 12 days. So you either need to go like off hours or like 30-second delay so that, there's 20 seconds where they can actually jump in. So now that you have the password hash equivalent, you do offline cracking. Then once you have the password, then you have to get back in. So you have to do another 12 days of getting past the second factor. Then once you're in, you can actually request for the second factor key, the 96-bit private key. And then you are a legitimate user, basically, of that person. Questions? Yes. Yeah, that's. Yeah. I have not actually checked. Anyone know? But yeah. Well, there are some that are. It's okay if you do plus, like with YubiKey. I believe it's like 64 or 96 bits of leeway, or of that you actually have to get right. So there's a leeway in the 128 bits that you have to send them to authenticate with. Of the 128 bits that you send them to authenticate with, there's like 32 to 64 bits of leeway. That it will basically decrypt to something that's valid. Oh, for for XX star. Wow, that was fun. I almost said their name. Yes, I guess you could technically do that, but you'd have to actually know everyone's. It's an email address that. Sure. Oh, I forgot to mention. With Star company, the two-factor obviously is required, which is. I know someone in this room was like, required 2FA. Screw that. They know who they are. Yes. So terrible password, 6-digit. Is it multiplied or? Oh, so the attacker already. Well, it would be like top key, the protocol top key or top key. The oh wow, that doesn't work too well. The ones that from the yeah yeah. So they check the second factor afterwards. Yeah, as long as there's well, unless they don't well, if they have rate limiting, then it's probably fine. Like if they lock you out for a long period of time after like a few guesses, and then you know, because usually with the 6-digit pin codes, it's like five in a million chance. It's time skew or count skew. But yeah, if you can hit the server like 100,000 times, then yes. Sure. Well, there was a problem when just recently. I don't remember his name or what he was a journalist who's like, "This is my real Twitter password," and then he just got spammed with like all these text messages trying to get through his two-factor, and he was like, "Yeah, that did not work," because then he like turned it off and he was like locked out of his shit show. But yeah, oh. I have no idea. I just went star, 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 star. Oh, no, no, no. I was just like. Yeah. Oh, I tried it. I didn't want to like run it for a very. Yeah. I then ran it for a little bit. Then I was like, huh, it seems to be working. But I'm like, they could be giving me back, well, fake no's. But so what I did was I generated one and then had that be at the end of like 100. So then it went through them all, then hit it, and I got in, and I was like, that's bad. Yeah. Yeah. Yes, thank you. There are probably other things I missed because that was only 30 minutes. Happens every time. Any more? Oh. Well, the legitimate user would have a phone that wouldn't work anymore, and there would be no. So basically, you would see, oh hey, my phone doesn't work anymore. Then they would actually go to the store. They'd be like, why would you think that my phone's stolen and give a new one to someone? That's what would happen. The more fun attack would be at a hacker con, just with USRP or something. But there's also the top key, second factor authentication apps, which affect that. Um. Uh. Split. Oh yeah. Oh. Okay. Well. Yeah. I was also going to talk about. Huh? Yeah. No, not that. I just remembered a part that I kind of forgot. I don't really remember what I was going to say. It's even better. Any more questions? Okay.